So a square pyramid, 35 mm sides of base and 60 mm axis length, rests on HP on one of its slant triangular faces. Draw the projections of the pyramid when the axis is inclined to VP at 45 degrees. So here, how to consider this, since it has to rest on HP, so obviously we have to start from HP. So how to place the pyramid, square pyramid? That is the first condition. So he says that one of the slant triangular face. So you have to place the triangular face, you have to place the square in such a manner that a slant triangular face has to be perpendicular to VP. So the slant triangular face, when it is going to be perpendicular, when one of the base edges containing the triangular face has to be perpendicular to VP. So that itself is going to give the, that itself is going to suffice the condition. So what is that? You can see here a slant triangular face. That means that is BC is the base edge which is containing the slant triangular face OBC, and similarly AD is the base edge which contains the slant triangular face OAD, and that OAD has to be perpendicular to VP. If OAD has to be perpendicular to VP, then naturally AD has to be perpendicular to VP. That is very simple. So by using this concept, we have to place the triangular pyramid, square pyramid, in such a manner that AD is considered to be perpendicular to VP. So once you consider that, now you can see here. So once you look from the front view, AB is near to the observer, so A dash B dash is visible. BC CD is away from the observer, C dash D dash is invisible, and O1 dash, of course, it is invisible. And when you look from the front view, I can see the height of 60 mm. So you can see the height of 60 mm. Then you mark this point and you complete the view. Similarly, when you look from the top view, you can see ABCD is near to the observer. So ABCD is visible. Since we have joined between OA, OB, OC and OD, this is a pyramid. So since it is from the apex point, we are joining to OA, OB, OC and OD. So these are called the slanted edges. So here that is also joined with a dark line OA, OB, OC and OD. And when you look from the top view, O is near to the observer, so O is visible, and O1 is away from the observer, so O1 will become invisible. So now you consider that in an orthographic view. How to consider? So first you consider a vertical line of AD, you mark that line, vertical line of AD, such that it is a side of 35 mm. So you mark that. Then from A, you again measure, from A you draw a horizontal line, and from also D you measure a horizontal line, and then with A as center take a radius of 35 and cut an arc on this to get this point B. Similarly from here D you cut an arc on this to get this point C. Then join BC. So you mark them A, B, C, D and then draw the diagonals. So the intersection point will going to give you at a point as O, and when you look from the top view, O is near to the observer, so it is visible. O1 is away from the observer, so it becomes invisible. So you mark them. Now we need to write the front view. Once you need to front view, so project all the points, all the edges from the points to the XY line. So here, once you look from the front view, AB is near to the observer, so A dash B dash is visible. CD is away from the observer, C dash D dash is invisible. O1 is, when you look from the front view, AB is hiding that point, so O1 is invisible. So when you look from the front view, since the height is seen, so here we are going to get O dash. So from O1 dash, since the axis of the pyramid is given 60 mm, so you draw a vertical line and you measure the length of from here to here as 60 and you mark that point O dash. Then O dash is visible, A dash is visible, so you dark this. O dash is visible, B dash is visible, so you dark this. Then A dash is visible, B dash is visible, so you are going to get dark there. Then join O dash and O1 dash with a center line with big dash, small dash, big dash, small dash. So here, since when you look from the top view, O dash, B dash, C dash is a edge, slant triangular face. You can see here, OBC is the slant triangular face. Similarly, O dash, A dash, D dash is a triangular face. How do I know that? When you look from the top view, for a front view of O dash, A dash, D dash, what is the top view of this OAD? So OAD has to be a triangular face. So you can see OAD is a triangular face. Since OAD will going to get a line here, so that means it is perpendicular to VP. Similarly, you are getting a vertical line here. You are going to get a line here. That is basically because it is a slant triangular face. Here you can see OBC is a slant triangular face. Now in the second position, he says that it is resting on one of the slant triangular face on HP. So here there are two slant triangular faces. One is this one and the other one is this one. If you want, you can keep it on O dash, A dash, D dash. Then you have to rotate left side. Since I want to keep it on B dash, C dash, so I am going to rotate right side. How to reproduce this? They measure the length from B dash to O dash. With B dash, C dash as center, consider any distance with respect to this. From here you cut an arc on this. You are going to get this point. Similarly, from here you measure the length from B dash to A dash. From B dash you draw an arc. Similarly, you measure the length from A dash to O dash. From O dash you cut an arc on this to get this point A dash, D dash. Then dark all these three views. You will going to get this three lines. Then you measure the length from B dash to O1 dash. From B dash you mark that point. You are going to get this O1 dash. Then join O dash and O1 dash with the big dash, small dash, which is a center line marking, which is a convention. Then we need to write the top view. Since we need to write the top view, when you look, draw a vertical projector from B dash, C dash, and draw a horizontal projector from BC to get this point BC. Draw a vertical projector from O1 dash and draw a horizontal projector from O1 to get this point O1. Similarly, draw a vertical projector from A dash, D dash and draw a horizontal projector from A and D to get this point AD. Draw a vertical projector from O dash and draw a horizontal projector from O to get this point O. Then complete the views. So how complete? You join between A to B, B to C, C to D and D to A with continuous thin lines. Similarly, you join between O to A, O to B, O to A, O to B, O to C, O to D with a continuous thin line, and then join between O1 to O with a center line, big dash, small dash, big dash, small dash, like that. So once you get this, now we are going to apply the condition of visibility. So the condition of visibility says all the exterior edges of the boundaries of the solids are visible. So here BA, OA, OD, BC and CB all forms the exterior edges of the boundaries of the solid, so it becomes visible. So when you look from the front, when you look from the top view, AD is near to the observer. So AD is near to the observer, so AD becomes visible. So AD becomes visible. That is quite evident here also. When you look from the top view, AD is near to the observer, so it becomes visible. So AD becomes visible. So we are left out with the option of OC and OB. Since OC and OB are crossing the visible edge AD, so two visible edges can never cross each other. So naturally OC and OB will become hidden edge. Since ABCD is totally visible, so O1 is on that boundary. So O1 is on that surface. So naturally O1 becomes visible. So O1 will be with a visible edge. Since it is resting on one of his slant triangular face, so naturally the axis will going to become inclined to HP. So you will going to get the apparent length. Now he says that the axis is inclined to VP. So since he has given the true inclination, but here once it is resting on slant triangular face, naturally the axis will be inclined to HP. Since the axis is inclined to HP, so you are getting the apparent length. The meaning of apparent length means what? It is always less than the true length. What is the true length of the axis? The true length of the axis is 60. So naturally this length will be less than the 60 mm. Now since he has given the true inclination, so we need to, since the second position top view shows that it is an apparent length, so we need to find out the apparent inclination. That is how we have to decide. So once you decide this, so we need the apparent inclination. So consider any point on XY line, then you measure an angle of 45 degree by using the compass and then draw a 45 degree line. And you measure the length of the true length of the axis, which is 60 mm. Consider any point on that 45 degree line and cut an arc on that 45-degree line to get this point. Then draw a horizontal line to get this a locus line. So then you measure the length from O to O1 by using the compass with the same point O, cut an arc on this locus. So you are going to get the inclination of beta, apparent inclination. So that you are going to denote by beta. Once you denote that by beta, so you know that we have O1 is fixed. Now you measure the length from O to this point. So from O you mark that point here. Then this line, that is AD, is perpendicular to O1. So by using the compass, you from this point you measure an angle of 90 degree with respect to O1 and draw a perpendicular line with respect to O1. Then from here, by using the compass, you measure the length from this point to A and also from this point to D. Both will have equal lengths. So from here you cut an arc on this side to get this point A, and from this point you cut an arc on this to get this point D. Similarly, you measure the length from O to this point. From O you cut an arc on this, or you have the one more method. Once you get AD, so from A you draw a perpendicular, and also from D draw a perpendicular. Why? Because BA and DC are perpendicular to AD. Since we have got this point AD, now from A, by using the protractor, you measure an angle of 90 degree with respect to AD. Similarly, from D also you measure an angle of 90 degree with respect to DA. Then you draw a perpendicular line. Then you measure the length from B to A by using the compass, which is same as that of DC. So from here you cut an arc to get this point B, and similarly from this point you cut an arc on this to get this point C. Once you get all these points, then you join all these things including the visibility and invisibility of the second position top view and complete this sketch. Remember, this sketch which has to be written, it has to be written on the beta inclination line, not on the 45-degree line. Once you get this, now we have to rewrite the front view now. So to write the front view, draw a horizontal projector from O dash, B dash and C dash. Draw a vertical projector from O to get this point O dash, and similarly draw a vertical projector from B to get this point to the XY line, and you get this point B dash, and draw a vertical projector from C and draw a horizontal projector from C dash to get this point C dash, and draw a horizontal projector from O1 dash and draw a vertical projector from O1 to get intersect at this point O1 dash, and similarly draw a horizontal projector from A dash D dash and draw a vertical projector from A and D to get this point A dash and D dash. Now you join A dash to B dash, B dash to C dash, C dash to D dash and D dash to A dash with a continuous thin line, and join O dash to A dash, O dash to B dash, O dash to C dash is already joined, and O dash to D dash with a continuous thin line. Similarly, you mark this center line with a marks with big dash and small dash. Once you complete this, now we have to apply for the visibility and invisibility. So how do we apply for visibility and invisibility? First condition is all the exterior edges of the boundaries of the solids are visible. So O dash, B dash, O dash, C dash, C dash, D dash, D dash, A dash and A dash, O dash, all are on the extreme edges of the boundary. So it becomes visible. Since and when you look from the front view, ABCD is near to the observer. So when you look from the front view, ABCD is near to the observer. So it becomes visible. So so you dark between AB. Now you dark between AB. Only the leftward portion is AC. So here D. So since D is the one which will going to be hidden. So once you have this, so you can see here ABCD is the surface which is near to the observer, it is visible, and B dash, O dash, A dash is a triangular face which is near to the observer, it is visible. So when you look from the front view, this is visible. So naturally OD becomes invisible. So here since A dash, B dash is visible, so naturally O dash, D dash is crossing the edge A dash, B dash. So hence it becomes invisible. So you are going to have an invisibility because two visible edges can never cross each other. So now the final solution for this is going to be like this. Here By looking at this figure, so we can say a square pyramid of 35 mm sides of base and 60 mm axis length rests on one of its slant triangular face on HP such that the axis is inclined to VP at 45 degree. Since we are satisfying all the conditions which is given in the problem, hence the problem is right. Even in the final position, you can see a triangular face of O dash B dash C dash is resting on XY line. Hence the problem is right.